Welcome to today's RBB Chat. I'm Carrie Gunther, RBB Sales and Marketing Coordinator. Joining us today is Phil Moeller of Symmetry Electronics. Hi, Phil.
Hi, Carrie.
Welcome. Today we're going to talk a little bit about UWB. So why don't you start out and explain what UWB is all about?
Good. So right off the top, so UWB stands for ultra wideband, and UWB is a fairly new radio technology that can enable accurate location tracking. And we're talking about less than 10 centimeter accuracy. So it's actually been used for specialty applications for the past 20 years, but there are now chips and modules which customers can use to expand it into more mainstream markets. I know NXP is kind of getting into the game now, but Symmetry's been a Decawave partner for several years. So, those are the products I'll be most familiar with. The technology operates in the 3 to 10 gigahertz range and is focused really around 6 gigahertz. The best application for the technology and premier use case is truly obtaining location information. It does also a 6 megabit per second secure communication link that can be used, which some applications may find useful.
So what makes UWB different than other wireless technologies?
Okay, so Wi-Fi and Bluetooth, they do offer solutions for triangulation in order to give some sort of distance measurements. And in some applications, those may be adequate, but really those are using RSSI for measurements, which can only give you granularity within meters, not centimeters like UWB. UWB was purpose-built for location, and specifically low-power location tracking. BLE, for example, has its own challenges. Bluetooth's angle of arrival is really in its infancy here and not ready to plug and play quite yet. It does have limitations on the range, probably maybe 15 meters there, whereas UWB are like 50 meters. And if you have reflections or you have to go through a human, it really hurts the accuracy of BLE. UWB does not have those challenges. So, and then there's Wi-Fi, which offers better range, but then there's power consumption issues, and still you're dealing with that lack of accuracy. And there's definitely some potential technology and solution overlap here. So UWB is focusing on distance and location. Neither are strong suits for Bluetooth or Wi-Fi, and they do see possibilities to replace NFC or RFID thanks to having near zero latency and an available secure data link that I mentioned. Time will tell if it can kind of overtake those technologies, but it could become a household name like Bluetooth or Wi-Fi.
What are some application examples where companies or designers are looking at UWB?
So within the last few months, as you can imagine, social distancing and contact tracing have really become huge areas of interest. And so there are a lot of companies developing products for those applications. Basically, you would wear a small pendant or a watch, and the sole purpose is to make you stay 6 feet apart from one another. And it'll beep or vibrate to tell you that, hey, you're violating the rule. The accuracy with UWB is actually good enough to reliably detect those kind of ranges. And there's a few different architectures for a UWB installation, so I won't go into those today, but there's simply point-to-point capabilities, or you can install anchors to track the nodes. In this specific instance would be the COVID. And as they move around a facility. So either way, it's just writing software to deal with the location data, which is provided by the UWB modules. I guess, unrelated to COVID too, there's a company called Shot Tracker that has put a UWB sensor inside of a basketball. And then each player will wear a tag on their shoe. Based on that, you can monitor who actually has the ball and watch where the ball moves around, where the players move around, get very good location for everything, for every shot. And then that's huge for the data analytics side. And even more exciting, so the iPhone 11 already has a UWB chip inside it. And there have been some recent announcements from Apple about how to write applications that can use that technology. Today they are limited to iPhone interaction, but this will be changing. I can't give you too many details there, but Decawave specifically has their next-gen chip that will have compatibility with the iPhone. And there's a wide array of other smartphones that will be hitting the market over the next few months. UWB's strengths have opened up opportunities inside of a pretty well-defined cell phone architecture, which, typically dominated by cell phone, Wi-Fi, and Bluetooth. But it's really going to be exciting as UWB gains momentum, and we start seeing companies find ways to use UWB to talk to a smartphone. And I will say, thanks to this adoption into cell phones, we're seeing potential in products like car keys or home security, your location, which your cell phone doesn't leave your side, it's truly known and precise in that phone. So, this will enable those smart door locks. There's Bluetooth versions of these products out there today, but there are issues. When you use a Bluetooth solution is near the door, does it know, is it which side of the door? And maybe there's a false trigger that you're not actually trying to go through that door. And even worse, to not even realize that you're approaching the door. So UWB is just a much smarter, cleaner, more accurate solution.
Exciting as designers are looking forward to what to do next with their existing products and how to move it forward. Exciting to see what these new designs might do. Thanks, Phil. Thanks for joining us today and sharing a little more about UWB.
Happy to do it. Thank you very much.
Thanks. Bye-bye.